In this problem here, we need to find all the factors and then state their multiplicities for this particular polynomial. To find the factors, we really need to find getting ready to find the zeros. So to do that, we're going to set f of x, or y in this case, equal to 0. And that just means we're going to try to solve it. I'm first going to see if I can do factor by grouping. Can I rearrange these in groups of 2 and 2, factor something out so it works? Again, unfortunately, this one does not work by factor by grouping. I do know it's a third degree polynomial, so there are exactly 3 zeros. I don't know if it's a combination of reals and imaginaries. It could be possibly one set of imaginaries and one real, or it could be 3 different reals, or 2 reals with multiplicities, or 1 real with multiplicity. To check it out, I'm going to graph it out on the calculator. So once you graph this one out, the graph you're going to get looks something like this. Okay, it's something like this image, and I'm in my standard window of 10 to negative 10 on my graphing calculator. It looks as though I do have an obvious 0. And if you second calculate your zeros, you are going to see that there is an obvious 0 at the number 1. They do want the factors, so I know that this 0 is the same as the factor. If I write this out, I'm going to put one of the factors already, is going to be x minus 1, which is the opposite sign. Again, third degree, so I know there's going to be 2 more factors for this answer. There could be multiplicity. I'm not sure if this does have multiplicity of 3. That would be my only option, is it's the multiple or factor of 1 with multiplicity of 3, or it is a combination of complex answers for the other 2. What I'm going to do is long divide this out of my polynomial. To get started here, to make x an x cubed, I need an x squared, and then I'm going to multiply that through. That's going to give me x cubed, and then a negative x squared. I need to come on and actually subtract that, so that becomes negative and positive. We now have, when we add together, a negative 2x squared plus 6x minus 4. I need to make an x a negative 2x squared, so I'm going to need a negative 2x. I'm going to multiply that through. This is going to give me a negative 2x squared plus 2x. I need to come on in again and subtract, so that becomes plus and minus. That's going to give me a 4x minus 4. Now to make x a 4x, I'm going to need to have a plus 4 in there. Multiply that through is going to give me a 4x. It's going to be a minus 4. And then when you change the signs here, that's subtract and plus, and it comes out to a remainder of 0. So I am left with this particular trinomial here. We have x squared minus 2x plus 4. To find the factors of that, I'm going to see, can I factor it into 2 groups nicely? I'd have to have x and x, and for 4, it'd have to be a 4 and 1 or a 2 and 2 combo to get negative 2. Unfortunately, this one actually does not factor nicely. It's not factorable, so the only option I have here is to actually use quadratic formula to solve it. So remember, quadratic formula, let me just briefly jot that down, is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My a value is here. This is my b value. And then the c value is there. So I'm going to come down over this lower section and actually do the quadratic formula. So if we solve that, I'm going to have x equals negative b would be a plus 2 or positive, plus or minus the square root of b squared is negative 2 squared, minus 4, a is 1, c is 4, all over 2 times a, which is 1. This is going to become 2 plus or minus the square root of, it's going to be 4 minus 16 all over 2. That is going to be 2 plus or minus the square root of negative 12 all over 2. That then is going to become an imaginary. So remember, you can pull out that negative square root, so it's going to be I. The square root of 12, I am actually going to keep this as a simplified radical, so 4 times 3. So square root of 12 becomes, if it's the square root of 4 times the square root of 3, becomes 2 times the square root of 3, and then all over 2. Technically, to get the complex number, what I have to do is this does break itself up into these two components. So that is going to lead me to getting 2 over 2 plus or minus I, 2 times the square root of 3 over 2. The 2's are going to cancel, so what we end up getting down here is 2 over 2 is 1, plus or minus it's going to be I square root of 3. So those are the zeros, by the way. Writing them as factors, this is a little higher level, but let me show you what the factors would look like. Again, keeping in mind we have one of the factors was x minus 1. Another factor would be x minus this entire number of 1 plus I square root of 3. And then the corresponding factor to that would just be x minus, again, 1 minus I square root of 3. So this is kind of a higher level concept of seeing these complex answers written as factors. I am not going to require this of you to have to do on a test. If it was the case, I would probably ask you to find the zeros. This is absolutely something I'd say, what are the zeros of this function? So let me go just that extra step further. The zeros of this function, again, it's a third degree, there's 3 of them. One of the zeros is 1, another one is 1 plus I square root of 3, and the last one is 1 minus I square root of 3. So there's 2 imaginaries and 1 real for the zeros. Again, if I were asked to write those zeros as factors, it would be this format. I would require you to write real zeros as factors, but not complex zeros as factors. This is very good exposure, though, for higher level math or taking a possible ACT exam. So hopefully this was helpful. It's a really good approach on how to do these problems.